the basics of cluster a little bit. So what's a HA cluster? HA cluster is basically a high availability cluster, which means it's a group of interconnected servers or nodes designed to ensure that a service or application or service remains available and operational even in the event of hardware or software failures. So in simple terms, we have a set of servers connected in a network, and we have resources which are available, and we want these resources to be available on all circumstances. Even if one resource goes down because of hardware failure or software failure, we do not want the service to be disrupted. So that's the idea of HA cluster. And this HA cluster takes care of doing the job for us. Okay. The cluster resources we can have many cluster resources. We can have resources like web server, can have database server, can have application servers as resources running in the cluster. Any service or any application resources that is managed and monitored by the cluster for high availability constitutes the cluster resource. Pacemaker is a software or an utility which is an open source software to manage the cluster resources for us, and it will keep monitoring the resources for its availability. And in case if it is something goes down, it will make the decisions appropriately. So we will see in detail a little more in a minute. That's a pacemaker. And the services we talked about, and we can also have services like virtual IPs. Virtual IP is a floating point IP that can move between cluster nodes, ensuring that the clients can always access a service even if the node providing the service fails. So the service, we talked about these services, web server, DB server, and application servers. All of these servers might be running in one node. If you configure a virtual IP as a service, and these services which were tied up will not get tied up to the specific node which it's running. Instead, it will get tied up to the virtual IP, and the service would be continuously available for us in the virtual IP instead of the actual node. That's a virtual IP is all about. File system is where we can configure the file system on the shared disk that we have, and we can also have that as a service available for the cluster. So these are the things. Few more things that we would be discussing. One is the pacemaker, second one is a Corosync, and third one is the PCS. These are the tools that we would have to work with to set up a HA cluster. And Pacemaker, coming to Pacemaker, it's an open source, high availability cluster resource manager that is available for the on-premises equipment. So we can use this for on-premises equipment that provides on a that works on a cluster of nodes to provide redundancy and failover for services. Responsible for making decisions based on the cluster states. So it's the one that's taking the decisions. So if you want to know the features, I have listed down few of the features here. Failover and recovery is one, and resource management is another. Cluster monitoring is another other feature, and we have concepts like features like constraints and policies, which means we can define a node or we can fix a node to run a resource, whatever the case may be. So that's a constraint and policies that we can define using the pacemaker. And other feature include it can integrate with a Corosync. So Corosync is another tool. Basically, it'll handle the messaging and membership of the nodes and the services ensuring that all nodes can communicate and stay synchronized. So this Corosync is a communication infrastructure that handles the communication going through in a seamless way between these nodes, and it will make sure that these services are available uh, at a high available, I mean, or highly available. Okay, so the next one is the PCS. PCS is nothing but Pacemaker Corosync Configuration System. So this is also a tool that interacts with both the Corosync and the Pacemaker to configure, monitor, and manage the cluster. So there's a huge list of CLI commands that is there for PCS uh, that we can make use of to configure the Pacemaker Corosync. We can configure, we can monitor, we can see the status, all that. We can do that using the PCS command line interface. So at a high level picture, if you see, there are two servers here. One is Alice and another is Bob. So these having a physical host. And on top of it, we have the pacemaker, which is running. And there's a Corosync is also running, which is taking care of the communication part between these two servers. So this forms the cluster stack over here. And on top of it, we have the services. The services would include web service, database, and whatever service that we would like to have. We can have the services running on this pacemaker. Okay, so pretty much that's all about the theoretical part. So we can get into the practical, demo thing. These are the steps, and we'll be seeing this step by step now. Okay, so I'm going to create two node cluster setup in my VM. There are few prerequisites that we have to keep it in mind. So I have given all of them here. So the prerequisite includes it will be better to have a host name instead of having an IP. So that's one thing. So something like this, I have given sent node one dot chosen dot local. That's a host name for first node. And the second node, I have given it a sent node two chosen dot local. So likewise, this kind of host name is better instead of having the IP address. So we can define these host names in these nodes. And we will have to make sure that the clock is in sync with all the nodes which are going to be part of the cluster. So let's see, both these things are taken care. So I have two VMs now. This is the SCSI server. This is a SCSI server, and I have this shared disk, which is SDA. This is a 5 GB, and this is my node 1, and this is my node 2. Node 1, I have created a logical volume out of the shared disk. Uh, this shared disk is showing here 5 GB, and the logical volume is named as LV underscore Apache, which is also going to get visible in this location as well, in this node as well. So this is the shared disk, which is available over here. Okay, so yeah, so we need to see the host names. I'll show the configuration for this host. This is host name sent node 1. So that's my host name. Host name minus F. This is a fully qualified domain name. So I've given it as sent node 1 dot chosen dot local. And over here, we'll see host name minus F sent node 2 dot chosen dot local. So how do we make it? Let me quickly show it to you. Cat etc host This is a file. I have given the entries here. So this is the cache file for DNS, domain name service. That is the mapping of the IP address for the domain name, and 172.15.0.11. So that's my node 1, and this is a fully qualified domain name, and this is my host name. And 172.15.0.12, this is my second node, and it is second node's the same host name. However, I've also given this SCSI server's IP address, which is this send
And
node 3.
yeah, the difference between this the domain name and the host name, we have to specify both, Alex.
Yes, Shafi. So this is the format for the host file. Uh, so we will this format include the format says like first is the IP address, second one
Okay.
is the fully qualified domain name. This would include the host name dot the domain
Okay.
name. Host
Okay.
name dot domain name. My host name is sent node 1. Domain name is chosen dot local, and my domain this so host name is sent node 1. So this is the format, and when we have this given, when we have given it successfully, and once it is successful, if we give host name minus f, we should be able to see this. If we given something not right, this will not show a right thing. So we will have to
Okay.
make sure uh, after entry, after making entries here, we'll have to make sure that host name minus f showing the right things.
Okay.
Yeah. Okay. So same thing, I'm doing it over here. And here hostname minus f says sent node 2 dot chosen dot local. Okay. Right. So eight, eight. Yeah. So if it's in sync, we can check uh, if both are in sync by using this command. Time date CTL over here, time date CTL over here, and NTP is synced, and yeah, so both time
And
zones are same.
where you configure NTP and Corosync?
NTP, we can configure like this over here. Time date TC, time date CTL, set hyphen NTP. Yes.
Yeah, but the backend IP address of NTP.
Yeah, so NTP is running by default. I think NTP is taken from the standard NTP servers that is there in the internet. So all that we have to have is the NTP server which is running. The standardized NTP servers should be accessible from this network, from this node. So currently, this is accessible to from for my NTP server that is running in the internet. And
So you're pointing the internet IP somewhere?
no, I'm not
Oh,
pointing anywhere. By default, it is picking the standard NTP server that is available. I'm not doing anything apart from this.
okay. Okay.
Yeah. And my aim is to not to go for NTP. I want to make sure the times are matching. So that's my aim here. So I didn't give much importance to where from it is picking the NTP server IP and all. So yeah, so that's what it is. My times are same. So these are the two nodes. I've configured the host names and time zones are same. Okay. So now that's the prerequisite, and then now we'll have this installation done. So that's second step. Config manager, set enable high availability. That's a complete package of tools that are required for the uh, the high availability is the repository
No,
name.
no,
We may have to
it's not the
enable
same.
it.
No,
Sorry, Safi.
no, exactly. Continue.
Yeah. Okay, so we may have to install this, and then we will have to give the firewall required for this enabling firewall service to be enabled in both the nodes. So using this command, firewall command, permanent add service is equal to high availability and reload.
Let's here.
So
Can you press, please, or hide this ribbon, please? In the PPT.
oh,
Yeah, because it's taking the screen.
okay. Is it clear now?
No, this ribbon, if you write, uh, if you collapse this ribbon. Yeah, in the ribbon, PowerPoint ribbon here.
Yeah.
Right. On the drop down,
So
right click.
is this okay now? Okay, let me make it full screen.
Yeah, it's better. Okay, like this. Because our screen is shrinking.
Mm-hmm.
Okay.
Okay. Yeah. So yeah, firewall configuration is done. And then once we make this installation, so this installation will create a username called HA cluster by default. So the username gets created when we install this. So we will have to give a password for this username HA cluster. So using this command passwd HA cluster. So that's a command to give the password for the username HA cluster. So using this username, the authentication happens. So username credentials, we authenticate the nodes that we want to add into the cluster. So this is one use, and the other use is when you use the web interface, we can use this this HA login credentials are being utilized. Okay, so next step is to systemctl start PCSD, systemctl enable PCSD. Repeat the above configuration for all the nodes in the cluster. Okay, I'm going to currently I'm going to demo it. Currently, pieces in the cluster is running right now, so I'm going to destroy this. So if you see here, PC status, it's currently running. Two nodes are there, node 1, node 2, and I have got 3 services. One is the file system, next one is the virtual IP, and third one is the HTTP service server. So I got this running now, and I'm going to destroy this and start from the beginning so that you will be clear. You will get to know this thing clear. Okay, so how to destroy? The command to destroy is to PCS cluster stop. PCS cluster stop all. So that's the first command that we need to give. This will stop the cluster. Stop the pacemaker and Corosync are getting stopped now. And next command is PCS cluster destroy. PCS cluster destroy. Yes. Okay, so now PCS, the whole thing is now removed. There's no node setup, there's nothing. If you see PCS status, you will not see anything. Here also, you don't see anything because you removed everything. Okay, so we are going to start.
So you destroy this. If you go back to this, if you scroll up, please. So you destroy this from any of the node or you run it on both the nodes?
I removed from one of the nodes.
If you go up, so you just destroy. Halas, PCS cluster destroyed.
Yeah, I just destroyed it, and then yeah, it is removed.
And what was the way to verify this one?
PCS status.
So it
PCS
will,
status. Yeah. So this is will tell that there is nothing which is available. Okay. So we'll do one after another. Start from the beginning. Firewall command to ensure HA nodes, HA in both nodes. This is done. This is actually done. I'm not
but
going
here
to
in
do
high
this.
availability, we are checking what this one, Alex. So equals high availability. So that is the high
Yeah, so
availability
that is
service we are adding this.
correct. Firewall command. See, there's a high availability service.
Ah, okay. Okay. So service itself, you are adding it. Okay.
Yes, service itself is I'm adding in both the nodes.
Okay.
Okay, and HA clusters as a username. This all these commands we will have to give it in both the nodes. So
One by one.
we will have
Okay.
to give it yeah. Um, yeah, both the nodes we have updated the username credentials for the credentials for the username HA cluster.
That is a step two, right? That's the one we are doing.
Right. That's a second. This is the step.
Right.
This one is
And be,
done. It's
okay.
done.
And now this start PCSD. So this one, how we can make sure before we start this service is already there? Because we run the package already, right? We
Sorry,
install the
Shafi.
package. This
Sorry.
PCSD package is already installed.
Mm-hmm. Yeah,
When in the
already
last class,
installed.
maybe?
So yeah, this is the step that already installed, and now we are going to start it.
Ah, so we installed this in the last class, this one.
No. You want to install it? Already installed this.
Oh, this is part of the cluster installation, our understanding, no? PCS,
Uh,
no?
yeah, Pacemaker, PCS, fancy agents, all PCP -0 conf. So
Yes.
these are the two.
Ah, so this one is installed before the class, you
Yes.
mean? Okay, offline, you mean?
Yeah, yeah. So yeah, yeah. I have done it offline, Shafi. You want to do
Okay.
it now?
No, okay, but normally we should do it during the class, no? Just for us to see the sequence. This is what I think we were saying.
Okay, let me just try this again. This is just setting the high availability repository. Repository is just set. Next command is the installation. That's it.
Okay, so this two steps has to be done across all the nodes which are available.
Correct. Yes. EPEL, I have removed it from the local repository because the size was too much. So I have removed it. So it's giving some error. After installation, I have removed this. The size was not there. I mean, it's very huge, so I have removed it. So already the root is 100%. So I just removed the EPEL. EPEL is huge. Here the packages are removed. That is why it is giving some error. Okay, we'll move on. Now we can enable the PCSD and we can start the PCSD. So command is systemctl start PCSD. Enable PCSD. Status PCSD. So this enabling PCSD can be done in only one node. It's getting reflected in the other node as well.
No, but at this time, so still we haven't linked the nodes, right, at this point? Or have we linked the nodes?
I have
No,
not linked.
yes, so we haven't defined, okay, how many nodes in this cluster is going to be, correct? In
No,
my
no. We have not defined. We have not defined yet.
So in this case, the running of this service should be individual, no? Because there is no communication as such as of now. I don't know how if I understand correctly, but for me, it's like both servers or both nodes are individual at this stage.
I'll show that once again. I'll do that once again. Here it is still running. So it's not connected.
Okay.
This is the states. Both are disabled now. So in the first node, let me enable this systemctl start CSD. The first node only, let me see the status. Here it is running. Here it is not running because I have not enabled. So I will have to enable. Now I'm going to enable now. So now the PCS is running in both the both the nodes. Next step. We completed till this. Next we'll go here. So we need to now we are going to add authorize both the nodes using the PCS command. So we will have to authorize both the nodes using the post authentication. So the command is
So this step will what it will do? It will link those for the to nodes or like what? Authorize in what way?
yeah,
This
it
one.
is authorizing that these two nodes gets connected.
Oh, okay.
Yeah, so these two nodes can be formed. So it's a process, it's a step in the cluster formation. So next
Okay.
step is the cluster setup. So for this this command, this should be a prerequisite. So we are tying these nodes based on a user credential. So once when we give this, we'll see this.
And
It'll
just a question on this. So let's say now when we start a cluster with two nodes, okay, and after due time, let's say we had the need to expand this cluster to add one more node. So in that case, we have to do the same thing here. We have to go back to the step and add here, or like no.
Yes. We may have to add. We may have to first authenticate the host with the credentials, and then we will have to add it to the existing cluster.
So is it using the same command or it will be different?
Yeah, this command will be same. Host authentication. I'm giving two nodes here, so I listed down two nodes. So in your case, if we are adding another node, we will have to give that node's name.
Yeah, because these two nodes is already there in the cluster, let's say. So now third one will come in due
Third
time.
one, yes. So
So
for
that
this,
time we need to specify all the three nodes again.
no, not required. No, so two nodes
No.
are already authenticated, and it is part
Yes,
of the cluster. It's working fine. Now we
yes,
will have to authenticate the third node
okay,
uh, to be part of the
yes.
cluster. So we can have multiple clusters based on the credentials. I think they are differentiating.
Okay. So only that additional node can be specified here.
Specified here. Yes, that's correct.
Okay.
Yeah. So once when we give this, it is prompting to enter the username. Now you
Yes.
must be you would get clarity. You will get some more clarity. So now I have to give the username I gave. The username is HA cluster and password same. So now you see it is authorized. It is authorized in this node. Again, I need to give the same command, but here as well.
So when you say authorize, he's validating this HA cluster credentials in both the nodes looks like.
Both the nodes, yes.
It should be same.
Right.
Hmm.
So these nodes are determined or reserved for forming the cluster with these credentials.
Okay. Okay. So we have, at this stage we haven't given the name of the cluster. Nothing has given, right? At this
No,
stage,
not yet.
only
So
only
that's
the
the
user
next.
is defined. Okay.
Correct. So that's the next step that we are going to do. So we have completed this one now. Second, next step is going to be the creating the cluster by giving a name. I given a name chosen underscore cluster. So that's a name that I gave with a PCS command in one of the node. We can give this now. If we can give this, so this happens in both the nodes.
Okay, there. PCS cluster. So
So this is
PCS
the
cluster
command
setup. So what is the name here? So PCS
chosen
cluster.
underscore
Okay, that is the name of the cluster. Okay. Then
start
start the host or the nodes. Okay.
two
Then port.
nodes. I'm actually forcing it.
Okay.
This can be done in any of the nodes, and the cluster is getting formed with these two nodes. Starting cluster on host, sent node 1, chosen.local, chosen.local. And if you see, now if you see PCS status, you can see the cluster which got formed, and the name of the cluster is here, chosen_cluster. That's the name of the cluster. Stone devices are not configured. Cluster summary is this, and there are node lists are these two. Both of them are online, they're connected. There are, at this point of time, there are no resources in this cluster. And PCSD is alone enabled, and Corosync and Pacemaker is not active or enabled yet. You see the node 2 PCS status. Same status. We have two nodes seen here, node 1 and node 2. And there are no resources. Name of the cluster is chosen_cluster.
Okay.
Yeah, okay. Okay, so now we may have to configure a few things. Just stone it. We are going to disable it because we don't have the ability or the power supply to do that. So this is one configuration. From now on, we can give it in one of the nodes. It'll be updated in both the nodes that is in the cluster. So I've just disabled or given false. And if you want to see if it is really false, you can give this command to check PC's property config. That's
What is this one?
configuration.
Property config, stone it enabled. Okay.
Stone it.
Stone it is enabled or not? Okay.
Yeah, just to see whether it's stone it is enabled or not. So just before that, I just configured false. Now I just wanted to make sure if it is really set to false. So PC's property config, if you give, so you'll get to know whether it is
Okay.
false. Okay. Completed this, we have completed this, we have completed this. PC's cluster enable all. So that's the thing. So that's the next step. PC's cluster enable all. So this will PCS cluster. This will start the Pacemaker and Corosync, both the nodes.
Okay.
PCS status. Now you can see Corosync is enabled, Pacemaker is enabled, PCSD was enabled already. Same status we can see over here. Okay, so now the cluster is set up. Name of the cluster is chosen_cluster.
But
This
just one
cluster has
question on this one. So here at this stage, what is the status of volumes? We mapped any volumes here? No.
no. We have just created two nodes and formed a setup.
Okay.
And we will have to have all the resources added to the cluster, and then only the resources availability will be taken care by the Pacemaker. Pacemaker
Okay.
needs resources to be highly available. So that's the job of the Pacemaker. We have just brought in Pacemaker. We have brought in the two nodes. We have just created the cluster now. That's it. Just we have
Okay.
created a cluster. We have to add the resource now.
Okay.
Okay, we have completed this part. Okay, now we are going to add the resources. We have the shared disk already. We have the virtual IP is also identified. I have another system. This is a system that I have. . 172.15.0.6. This is the virtual IP that I have already. This is part of this network. The system is part of this network. And I'm going to configure this as the virtual IP. And we have the disk and the file system, the shared disk and the file system as the next resource. And the third resource is the HTTP service. So HTTP service is what we are going to create now. So first we need to install the HTTP service in
So just to
both the
summarize,
nodes.
we need how many services now? First, mandatory is HTTPD and
HTTP
virtual IP
virtual IP and the file system.
file system, which is the volume. Okay.
Yeah, which is the volume. And if HTTP service, I've given it for a demo purpose. We can have any other things. So virtual IP and the share volume would be a requirement mostly, even if we have any other services. So database service or any other service, we will have to have these things at least should be there. Okay, HTTP service resource, what we are going to do is actually we have to install the HTTP server in both the nodes and start it and enable it. And these are the commands. I have this HTTP running in both the nodes.
Installed already. Okay.
I've installed it. I can start enable. HTTP service is running in both the nodes now. There's one configuration that we will have to do in the HTTP server file, server configuration file. And this is the one, the location directive controls access. So there's a directive that we will have to make. And this is the configuration which says server-status. So this is a default page. And we can have this page available only for the local host. So what I mean is if we go to the nodes, specific nodes browser, we will be able to see this health status of the web server. So this is a configuration that we will have to make it in the http.conf file, which is present under the etc directory. So we'll show that. We'll do that http.conf directory. So this is the file, and the last location, I've given this location slash server status, server-status require local and location. Same thing is done here as well.
So until now, you haven't formed the virtual IP till now, right? You haven't reached that stage.
I have reserved a machine in the network. I have not configured the cluster virtual IP as the cluster resource. I'll be doing it now. So HTTP service configuration, this is installation is done, enabling is done. This configuration is also done. There's one other configuration to suggest, that is to make the log rotation. So the log rotation of the services will be while doing the log rotation of the HTTP service, it will by default, it will restart the web server also, it looks like. So we may have to do a specific configuration. I'm going to skip this, not doing it, because we are not running it in a production environment. So there's no point of having log getting filled up. So I'm skipping this. And then now I have this logical volume already created, and this part is already done. This is the shared disk. So this is the HTTP service, which is the logical volume, shared logical volume. So this is already done. We have this thing, which we could see it over here. So this is the VG Apache, LV Apache. And here also we can see that VG Apache and LV Apache 5GB. So both these things are available. This shared disk is available in both the nodes. Now, and
So
now
this is the same. This is one disk, but visible from both the nodes. Is what you're saying?
correct. Yes, that's a iSCSI thing which is coming up, which is shown over here.
And what is the communication between these two nodes and hard disk? Over IP or like over?
Corosync. Sorry, I didn't get your question.
No, this is hard disk, right? This is external hard disk, like storage.
Correct. And this storage is coming from the iSCSI server. These two nodes
Okay.
are iSCSI
Okay.
clients. So iSCSI protocol taking care of making this disk available to these clients.
Okay.
Yeah.
And you are using ACTE for okay.
Okay. And now what we are going to do is I'm going to add a small web page in the shared volume. For that, I'm going to mount it in a location. So mount it in a location and then do that. Mount it, mount /dev/ which Apache. Mount it under this location. Var. Sorry. Var. Under this location, I have mounted, and you can check this by giving fdisk minus h. Sorry, df minus h. So this is a shared disk which is now mounted over here. And in here, I'm going to add these directories were already, there's a requirement to create CGI bin error HTML. So this was already created, so it is actually showing up. And I have created an index.html file and the command to create the index.html file. So these are the three commands, mkdir to create a HTML directory, CGI bin directory, error directory. All of these things are done. And this is the command to create a small web page. If you see index.html, you will see that over here. So welcome to chosen HA cluster demo page. This is a small information created in a HTML page, and that is stored as index.html. Okay, so it's already done. So this content is already present. So after done, so I'm going to unmount this. You mount. I unmounted this. Now there is nothing available. Okay, and next one is HTTP also need to be added as for the in the firewall. So that's also done already. Okay, so now we have all the resources created and now it is available. And now we will have to add these resources
Wait,
into the cluster.
okay. So I mean, we create only one resource here, no? That is HTTPD.
Yeah, HTTP alone we have created. We have created specifically, all other things are already there. We had the shared volume already created. We have the HTTP we have just now created. And I have reserved a virtual machine for virtual IP. So these are the three things which I have it ready in my hand. Now I'm going to add all of these resources into the cluster.
Okay.
Yeah. So the command to add the resources into the cluster is this: PCS resource create, give the resource name, your own name, and you can give the resource agent and the resource option. So this is the syntax for adding a resource. And the command to add the shared volume is this. So there is a resource group I am creating and given the name as Apache. So I'm going to give in any of the nodes, I'm giving this in this node. The command is this: PCS create, PCS resource create, HTTP d_fs, and that's a name that I have given. The file system device, which is here, and the root directory over here, which is here, which is this. And file system type is ext4. These are the options. And the finally, the group name, the resource group name, it is part of the resource group name, which is Apache. Hitting enter. Now added this resource into this cluster. This is done. Next one is the virtual IP. So virtual IP is 172.15.0.6. So we'll make sure that we are pinging. We are able to reach to this. I'm able to reach this. Command to add the virtual IP is this. I've given the name as HTTP d_VIP and IP address 2 ADDR2. That's the IP virtual IP's syntax I've given here and made it part of the group, which is Apache. Now second resource is also added. Third resource is the web server. The web server resource I'm going to add now. The name of the service is httpd_ser. Apache config file. The config file is present over here. And status URL is defined here. So this is what we had given in the location directive in the configuration file. And this resource is also part of this group, resource group Apache. Hitting enter. Yeah, so all the three resources are now added to the PCS. And if you see PCS status, you can see these resources have got added. The three resources are now listed. Resource group name is Apache.
But where we mention this Apache resource group name?
We have
The
given
command
no in the command Apache.
for
In
this
every command
service.
we had, yeah.
In every command. Okay.
At the end we gave this group
So here, as of now, we just create a VIP as a virtual IP, but
file system.
we haven't yet mapped what services behind this virtual IP, right? What host, let's say. Let's say the external, for example, the outside the node, any other outside node. If he wants to communicate to node 1 or node 2, he should communicate through VIP, this VIP, correct?
Correct.
Okay, so where is this mapping we defined behind this VIP?
No, I think no, there's nothing is done like that. So virtual IP in cluster, when we define, so it is part of the pacemaker feature. So if you remember, so I told that there's a feature, the pacemaker virtual IP is supported. So we may have to tell this resource is tied up with this virtual IP. So right now, what we have told is this resource, that is the web service resource
Yeah,
is
yeah.
tied up with a virtual IP in this resource group, and this is part of this cluster.
Okay,
This
yes, this
IP
is
will
clear.
be there in IPA. The adapter will be replaced with this IP now.
No, no. So the cluster resources are available through this virtual IP for the external entities. We don't need to bother about the nodes IPs now.
I agree with you.
Node
Yeah,
is
this is
having
the intention is clear, but is there a way or is there some step we did to point, or it's just like, okay, we define that under this cluster, these are the two nodes. This one we saw
yeah.
it. So now then we see this separately, parallelly we created the resource, virtual IP, HTTP,
And we
and this
have
folder.
created this command, no? When we added this command, this is the resource creation.
This one is resource creation. So we are creating VIP as a resource. But behind this
Yes.
VIP, how many nodes are there where we define it?
No,
We
no
didn't,
need.
no need.
No need.
No, no.
What Shafi is asking is like now we know, right, we are going to make a cluster with two nodes.
Right.
How the system will know that my cluster is with two cluster node?
That's what. No, I got your question. So basically, virtual IP is an IP which is being used for by the cluster. Cluster is actually acting like a virtual environment. So if you
Okay,
see here, this is my 172.15.0.0, 15.0.6. In here, I am not even running a HTTP service. No HTTP service is running here. So this is a dummy IP, which is a dummy node is there for accessing the cluster resource.
okay, okay. So I think when in one place when we are defining the cluster, we mentioned these are the two nodes under this part of cluster,
Yeah,
and then parallelly we create the resource, uh, VIP resource that will automatically map the number of hosts under this. This is what it looks like. PCS by
correct,
PCS.
correct. Yes, that's correct. That's correct. So basically, how it is working is that the virtual IP is actually tied up with the active node. Active standby is coming into picture. So, and this
Okay.
is being taken care of by the pacemaker. So this is the job of the pacemaker, core job of the pacemaker. If you see, this is the pacemaker is the
Okay.
software
So here,
responsible for redundancy.
he- here we just define the number of nodes we want in this cluster, and then we create the virtual IP. So the
Correct.
pacemaker will auto map this one.
Correct.
Okay.
So pacemaker is doing the uh, active standby election. So there is a many jobs that are doing. So there is a. I mean, if we it's a currently it's a two node cluster is not a very good thing to demo it. Actually, two node there is a quorum which is taken into consideration. We can define the priority for the nodes. So these nodes, so there are few calculations here, there are there. Some things are there. So based on that, he will conclude on an active node. And this active node's IP is what is tied up with this virtual IP.
Okay. Okay.
Yeah.
Okay.
Yes. Okay. Oh. So now this two services are running, and third service is not running because it says some issue on the resource agent did not complete within 40 seconds. So this is an issue that in this setup which is happening, and it is going off when I restart both of these nodes, and it is saying that it is taking more time for bringing up this service in the cluster. So at the moment, it is getting resolved by when I restart both these nodes. I am restarting now. Let it restart. Meanwhile, we'll so verifying the cluster. So once we have this service, all the services which we have brought in should be up and it should be in a active state. So currently it was showing a stopped state. So it should not be like that. It should be in the started state. It should be in the active state. Once that we can verify using PCS status and PCS resource status. So if once we see all of these services are up and running within the cluster context, then we can go ahead and put in the browser, we can say type the virtual IP, which is 172.15.0.6 in one of the nodes, and we will be able to see the web page, actual web page. So that's how we can verify the HA cluster. So this is the virtual IP. So 172.15.0.6, that's the virtual IP, if you remember. That's what is the virtual IP. Yes. I'm going to show. This starting state, it should be started. It should be in the started state. I'm going into one of the server, one of the machine. So CentOS VM3 is my ISKC server. I'm going to take this. There's nothing here. There is an external client or external person that we can imagine. If you see config, and this IP address is 172.15.0.17. So in this, I'm going to take my Firefox and I'm going to 15.0.06. So this is the virtual IP. And if we access through the virtual IP, we will be able to see the HTTP service active in this virtual IP. So immaterial of the nodes, node 1 going up or going down, node 2 going up or going down. So this service is available for us on this virtual IP. So that's the cluster advantage of the cluster, high availability cluster.
Okay. Okay, Alex. Yeah, got it.
Yeah. Okay. So that's what it is. So next one is actually some commands here. I have listed down some of the commands. PCS cluster start all, PCS cluster stop all. If you want to destroy, this is the commands that we have to give. Give you the cluster resource, we have to give PCS cluster resource status. To remove the cluster, these are the commands. Failover verification, we can give PCS node standby. We can put one of the node in standby mode. And if you want to bring it back, we can put it in the unstandby mode. So these are the commands to bring it to standby active. So in a 2-node cluster, it requires careful configuration of quorum. So quorum is not there. If you remove one of the nodes, there should be a fencing mechanism, because there will be a split brain scenario. That means like 2 sets of nodes will form their own cluster, and it will go into an unstable state. So uncertain state. So due to lack of quorum, so we will have to add a queue device to demonstrate the standby active stuff.